Hello. Today we're going to have a short lecture on vehicle routing problem. This is kind of a problem that we try to optimize routing or delivery path so that we can minimize the cost or time or of any other risk, or sometimes also maximize profit. This is a very classical kind of problem in a classical issue of travel salesman problem. That is, if you have a number of points where customers live and you want to make some delivery to them, what will be the optimal routes where you go to visit every single customers one time to make delivery without returning to them? So from a particular starting point, you have to have a way to economize the routes that you take so that you can take the shortest route to deliver necessary products to all customers. So this is a typical classical travel salesman problem. This kind of problem is particularly important right now when we all stay home because of the coronavirus. People purchase online, and therefore those delivery companies, FedEx, UPS, and Amazon, even a U.S. Post Office, when they have the products to be delivered to a in an area, they need to figure out the best way to make deliveries so that you do not have to back and forth. You have to go always pass through the same points, wasting a lot of time. So this is the kind of problem that we try to solve in vehicle routing problem. Is a kind of under a general umbrella of a spatial optimization. Now here on the screen we see this travel salesman problem, and this particular problem is that if we have all these consumer locations and we have one depot. The depot is this location where the delivery business located, and from this point, what would be the best route so that it can go every single point just one time and you complete delivery. So this classical travel salesman problem assume that we have only one depot. One depot make delivery to all other businesses. Okay, so this is a classical salesman travel salesman problem, because this is when you use a computer to make calculations, there's some measure of randomness into it. So there's a possibility that you may not come up with a single solution. So theoretically, there ought to be a global optimized solution. But in reality, a lot of times computer programs, if you search every single possibilities, that would take a lot of time. It also may exhaust the computer power. And they come up with some local optimized solution. And therefore, if a local optimized solution may not be as good as a global optimized solution, but a lot of time it's just probably good enough. So that's why when you use some computer program that largely rely upon the local optimal solution, in different runs for the same problem, you may come up with a different solution. As in this case, you see on the screen, you see two runs, you may come up with two slightly different solutions. But in practice, this kind of localized optimal solution may be just good enough. Okay. Also, you have a multiple travel salesman problem. What if you have two depot? You have one business that have different branches. This is one business office, and this is another business office. They cover up the market into different sub-regions to optimize the location, to optimize the delivery location. And in this case, we have could have one business that divide into different location, a different sub-region market, or you could have two different delivery businesses, and each serve their own local market. And this picture on the right, that you have 3 depots, and you could have more depots. And sometimes you also have that 2 depots, and each depot have 2 vehicles. In this case, we assume that one vehicle did all the delivery here, but you may have 2 vehicles, and how we're going to solve those kind of problems. Okay. So in addition, there are also so-called capacitated travel salesman problem. That is not only you need to consider that you want to minimize the travel distance or travel time, but also at the same time you need to consider the amount of delivery. When you drive a vehicle, the vehicle has certain capacity to hold the material to be merchandise to be delivered. Different consumers may require different amount of delivery, but a vehicle's capacity to hold the merchandise maybe it's limited. So therefore, in part because of this kind of problem, you may have 1 depot, 2 vehicle or 3 vehicle problem, because one vehicle has limited holding capacity and to deliver all the product that is required. That's why you need additional vehicles. When you have additional vehicle, how those different vehicles should take their own routes to minimize the cost, the distance, or time that is used to deliver those amount. Okay. Therefore, there's also issues like number 4, vehicle routing problem with time windows. So if you, in ideal world situation, we do not want people come knock on your door at midnight and telling you that, hey, we are shipping your product right now. You always want the product to be shipped during the daytime when you're available to pick up the merchandise that to be delivered. So this kind of issue can be very quickly become very complicated. So we're going to have a project 2, to solve the vehicle routing problem using a very nice worksheet based on Excel. After we solve the optimizing problem in Excel, we can do visualize using R script to generate some data. Then we bring data into QGIS to make very nice looking maps. Okay. All right, so we finish our lecture now. We're going to have our project to deal with the vehicle routing problem. Okay. I see you next time. Goodbye.